In this lesson, we are going to learn how to determine the net ionic equation, or NIE. And the concept of net ionic equation is that when we have two solutions and we mix them together, how do we know if there is going to be a reaction? And basically, there are steps. But before we look at the steps, we need to realize a reaction only occurs when we mix two solutions together. We need to form one of the following products. One of the products, of course, is going to be the insoluble precipitate, which is the solid. Or the other products in this case is going to be liquid H2O, which is water. Or we can have a formation of gas. Because if you produce gas, the gas is going to escape from the solution. When we produce the water, the hydrogen bond in water will keep the water molecule together. And also, when we produce the gas, it's going to become a gas and it's going to escape from the solution. And when we have a solid precipitate, it's going to remain a solid. So let's go back and look at the steps to determine the net ionic equation. First of all, of course, we are going to be given two solutions. And how does that work is this. Let's use this as an example. In this case, I have a solution of lead nitrate. And I'm going to add in a solid, sodium chloride, table salt, to see if we're going to have a chemical reaction. Now, does it matter if this one is solid or aqueous? No. As long as one of your solution is aqueous, the other one can be a solid as well. So let's go back to look at the steps to determine the net ionic equation. The first step is to exchange the ions between the soluble compound. That is, you combine the positive and negative ions to make a new compound. In this case, I have this right here, lead nitrate. So that can be separated into lead 2+, and nitrate NO3-. And of course, they will exist as aqueous ions. And for the sodium chloride, we would have the positive charge of sodium and the chloride ions with a negative charge. So to exchange ions, you combine the positive and the negative. Basically, this negative formed with that positive, and this positive formed with that negative. And then we're going to go to step 2, look for the possible product. In this case, we have to apply the solubility rules. Okay, so use the solubility rules to determine if a substance will be soluble or it's going to be a solid precipitate. In this case, I know nitrate is always soluble right there. So therefore, it's not going to make any product that we're going to look at. And then the lead chloride. Chloride is coming from group 7 with the exception of LMS. L is for lead, M is for mercury, S is for silver. So in this case, what we have here is an insoluble product. So this is the product that we're going to make. So we have a chemical reaction. So that is step number 2. So in this case, we would have lead. But what is lead? Lead is Pb2+, where chloride is Cl-. And when we combine them together, we are going to have PbCl2, because the charge needs to be cancel each other out. Now the next step is when we have our insoluble precipitate or the product, that's either water or any gas, and we can think backward to determine the reactant, which is already given to us in here. So what are the reactant ions that's going to make this product? First, of course, we know this is going to be Pb2+, and that's coming from here as well, Pb2+. And what about chloride? That's going to be chloride ions. And of course, this will be in aqueous state of matter, where this one is going to be the solid precipitate. And the last part of step 3 is we have to balance the chemical equation. In this case, we have 2 of the chlorine atoms right here, so we have to put a 2 there. And there we go. We have our net ionic equation. And what about the ions like nitrate and sodium? Those ions does not involve in this chemical reaction, and they are known as spectator. The term spectator, that means they are just there to watch the show. In this case, lead and chloride ions are the only two that's involved in this chemical reaction. Let's try another problem. In this case, I have magnesium hydroxide and hydrochloric acid combined together, and they're both in aqueous. So let's go back and separate our ions. We have magnesium 2+, and then we have hydroxide minus. So you need to know your ions, okay? And over here we have H+ and Cl-. So we exchange our ions, positive and negative. So this negative form with that positive, and this positive form with that negative. But in this case, OH- or hydroxide and H+ make water, which is one of our positive products. So this is H2O. So that's good. Where magnesium and chloride, if we go back to our solubility rules, group 7A will be soluble except with LMS. In this case, is with magnesium. So this is soluble. So what we're going to make is water. So we have H2O in a liquid form. So step number 2 is done. Now let's go to step number 3. We think backward, and this product of water is formed from, of course, the two ions right here. So in this case, is OH- in aqueous form and H+ in aqueous form as well. And is the chemical equation balanced? In this case, we have 2 hydrogen and 1 here and 1 there on the reactant. So it's balanced. And we have 1 oxygen and 1 oxygen. So it's balanced. So we are done. And of course, Mg and Cl, they are spectator ions. Let's try another problem. In this case, I have sulfuric acid right here combined with potassium. Now let's separate this and identify the ions. So we have H+ right there. Notice how I don't care about the subscript for now. I just find the ions. And this is sulfate, SO4 2-. And over here we will have potassium plus and Cl-. And we combine them together and we exchange ions and combine to make new compound. In this case, if we go back to the solubility rules, group 1A will always be solubles right here. Okay, so therefore this is soluble. And then we have H and Cl. Group 7A is always soluble except with LMS. In this case, it's not with LMS, so it's soluble as well. So what we have here is just a bunch of ions mixed together in water to make a solution. So we have no reaction because they will never form a solid product or precipitate. And so the answer is no reaction.